EUMETSAT in Darmstadt, Germany is an intergovernmental agency established in 1986 to develop and exploit meteorological satellite systems to deliver data for weather forecasting.
Today, we operate 10 satellites in orbit and we deliver data to 30 member states. The priority of EUMETSAT is to deliver the best observation for weather forecasting. It means we need to have the best satellites and also the best science to extract information from the observation of these satellites. It's important to understand the value of weather forecasting for society. Not only does it save lives, as everybody knows, but it's also vital for the economy. For instance, civil aviation does not exist without weather forecasting. Studies have shown that the socio-economic benefit of our satellites in the European Union is more than €5 billion per year. Since 2000, a second mission is to monitor climate change. So EUMETSAT is at a key point in its history. First, we are preparing the next generation of our satellite systems. And second, we are also exploiting new satellites on behalf of the European Union for the Copernicus program.
METEOSAT second generation is EUMETSAT's current geostationary program, and the third generation is already well underway.
The new fleet of satellites will provide for the legacy service for the imager mission a higher temporary and spatial resolution. So with this, the observability of the meteorological information will be better. For the new mission which will fly on the imager satellite, we will have a lightning imager. With the sounder satellite, we will provide new information on the composition of the atmosphere. In order to develop the user requirements, there was a long user consultation process in the beginning to develop the user requirements document. There is an ongoing mission advisory group for the new missions. And for the legacy services, we are consulting the users via the science and operations working groups.
Metop is a series of 3 polar orbiting meteorological satellites and forms the space component of EUMETSAT's polar system, or EPS. Metop A was launched in 2006, followed by Metop B in 2012.
The third satellite, Metop C, is identical to the first 2 satellites, A and B, and will be launched next year in 2018 in the last quarter. This satellite, even 20 years after its design, is still a state-of-the-art in this domain. It does a lot of observations from a low Earth orbit and provides data to our users, which are essentially numerical weather prediction centers, but also climate monitoring centers. The EPS second generation, the new satellites that will be designed and the system around those satellites will continue the missions of the first generation with better accuracy. These programs generate data that have a lot of impact for the society. The programs EPS and EPS second generations are based on cooperations which are worldwide. We built our first system in cooperation with the US with exchange of instruments, data and services, and also in Europe, where we have cooperations with the European Space Agency, who is in charge of developing our satellites, but also with some national agencies such as CNES and DLR to do some development of instruments which are state-of-the-art instruments.
One satellite operator, be it national or European, cannot deliver all observations needed for weather forecasting. So we need to cooperate with the US, with China, with India, to coordinate our observing systems, to share data such that our member states in Europe have access to all data they need. And this we do in the framework of the World Meteorological Organization. EUMETSAT means 30 member states join their forces to get the best possible satellite and data. EUMETSAT is exploiting Copernicus satellites on behalf of the European Union. And these satellites are dedicated to the monitoring of the ocean and atmospheric composition. And we do that because there is a lot of synergy between the observation we deliver with our own satellites and these new observations. And it's very important for users to access all these observations together.
EUMETSAT is a user-driven organization, developing data services and constantly adapting to the evolution of the requirements of its users.
EUMETSAT produces over 100 products from our 10 currently flying satellites. We cover everything from classic meteorology, which is our core mandate, but we also address new areas such as the state of the oceans, the height, the quality of the water, the biological growth, as well as looking at air quality, which is of great importance to us around the world. EUMETSAT develops its products using the classical scientific approach, which is exchanged with specialists following scientific developments that are published in literature. In addition, and this is really a core part of our business, is to actually listen to the varied user communities that give us feedback through our help desk and those elements. And last and not least, we also have a mechanism with our member states where we actually meet twice a year to discuss the state of our products and developments.
Modern weather satellites can be used for much more things than just to support the weather forecast. 20 years ago, EUMETSAT took a wise decision. They decided to exploit the expertise and the skills that is already available in its member states, so across Europe, and to use these expertise to develop tailored products that support directly specific user communities. The satellite application facilities are in a very intense contact with the users because they have to understand both worlds, the application areas, what the users want, and also the satellite technology. So communication with the users is essential for them to work with them and for them, and to provide them the information from satellite data they need for their applications.
The vision of the future of EUMETSAT is very much driven by the evolution of forecasting. I don't say weather forecasting because today forecasting is much more than the weather. So the vision of EUMETSAT in the future is to deliver seamless observation of the ocean, the atmosphere, the atmospheric composition for integrated forecast of weather, air quality, ocean.